Okay, here we go. Day 8. Welcome back. We are working through Advent of Code in Ruby. Currently on day 8. Had a couple days of optimization problems. The picture's starting to come together. Excited to see what this ends up being. I'm guessing it's looks like it's underwater cave of some sort. Anywho, a little under an hour before I have to join stand up, so gonna get to it. Day 8. Day 8. 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the 7 segments named A through G. Each digit of a segment is rendered by turning on or off any of the 7 segments named A through G. Got it? Okay. So to render a 1, only segments C and F would be turned on. So A, B, C, D, E, F, G. Got it. Okay. So to render 1, only segments C and F would be turned on. The rest would be off. To render a 7, only segments A, C, and F would be turned on, etc. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections, though. So, you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. I'm getting some pop-ups here. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are meant to be on. With just that information, you still can't tell which wire goes to which segment. For that, you'll need to collect more information. For each display, you watch the changing signals for a while, make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. A, C, E, D, G, F, B, C, D, F, B. Okay. The entry is wrapped here to 2 lines so it fits. In your notes, it will be one single line. Cool. Each entry consists of 10 unique signal patterns, a pipe delimiter, and finally the 4-digit output value. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB in the above example means that to render a 7, signal lines D, A, and B are on. Because 4 is the only digit that uses 4 segments, EAFB means that to render a 4, signal lines EAFB are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. You should be able to work out which combination of signal wires corresponds to 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. Okay, for now, focus on the easy digits. Consider this larger example, etc. Because the digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals corresponds to those digits. Counting only digits in the output values, the part after pipe on each line, In the above example, there are 26 instances of digits that use a unique number of segments. In the output values, how many times do digits 1, 4, 7, or 8 appear? So looks like for part A, we don't actually need to solve this. We actually just need to count the number of times digits 1, 4, 7, or 8 appear, and we know that because 1 is the only one with 2, 4 is the only one with 4, 7 is the only one with 3, and 8 is the only one with 7. Okay, so part 1 seems to be pretty straightforward. There's a little bit of parsing that needs to be done, but it looks like I should be able to get moving pretty quickly on part 1. I've been using problem input, but it actually calls it puzzle input, so I'm going to change that over on day 8. Okay, so we've got the puzzle input. We've also got test input. And this test input is here, and I actually am going to probably actually use and puzzle input. These actually all in one line, so let's join those so that we can use the same method for inputting these. It looks like part 2, though, it's going to be doing something like Sudoku, where you kind of you take all the candidates that the thing can be, you remove any of the ones that aren't. Once you know one, you can start peeling the others or figuring the others out. So if that's where part 2 goes, I kind of have I think I have a strategy in my mind of how I might go about that. But for now, let's see. This is a 7-segment display. So we've got a segment display. We've got a signal pattern decoder. Each entry. Right, so the 7-segment display will be what we've got, and we can actually just figure out how many of, we've got a bunch. Wire, so let's see. You notice that the 4-digit display is malfunctioning. What are these supposed to do? What are the 7-segment displays supposed to do for us, though? They're supposed to give us numbers, but it doesn't say why we need the numbers. How many times do digits 1, 4, and 8 appear? Okay, so what we've got is a 7-segment display. And we've got a spec. And this require our spec, require relative 7-segment display.rb. And we know that we're going to have class 7-segment display. And then we can we only need one method here. We just need to know the number of, and the output value is unique number of segments. So 1, 4, 7, and 8. Let's say easy or unique segment count. 1, 4, 7, 8 count. That's a silly name, but there's nothing really. Easy digit count. Easy digit count. It seems like a good name for this, because if part 2 goes where I'm expecting it to go, then it will not be used in part 2. So we can go ahead and just go through this. It is. I don't have a good way to name these, but it is 2 when there are 2. It is 0 when there are 0. What's another? It is 3 when there are 3. I don't necessarily need too many of these tests, but let's say it includes, it counts a 1 digit, counts a digit with 2 segments. It counts a digit with 3. And let's see, 4 is 1, 2, 3, 4. It counts a digit with 4 segments, and it counts a digit with 1, 2, 3, 4 with 7 segments. Kind of a lot of tests, but I can probably get rid of this one. Okay. So test segment display equals 7 segment display dot new, and it's going to take the display is only going to have the second half, huh? Okay. Nah, let's just give it the whole thing, because it feels like the decoder. Let's see. Yeah, maybe it's going to. We'll do decode with a decoder. So I think getting ahead of myself, but for some, if they're giving how to solve the problem, but then not asking you to do it, you're probably in for solving that problem. So we've got that. Let's go through this, paste this here so that we can fill in the starting point. So there's 2. So that one should expect test segment display dot easy digit count to equal 2. When 0 when there are 0. We can just get rid of this, and 0. Okay, So here we can just, let's only have one. So actually this one's 1 with 1. And expect test segment display.easy digit count to equal 1. And then we can actually, use that same expectation, but change the setup here. Change that CB to for 3 segments. Doesn't actually, I guess it doesn't have to be VGA and CBGAE. It's not going to be right, but it doesn't matter at this point. Still on our specs. All these are wrong. Def initialize. Display and easy digit count. Our spec, we got nil. So here we do display.split on. So display is an array, and it's split up by split on space to split the different numbers, and then the easy digit count is display dot sum digit, or display dot select digit. Let's see, can I do length 1, 2, 3, 4, 5, 6, 7. Yep, okay. So digit dot length. Oh, actually, we can do. We know it's 2, 3, 4, 7. Dot include. Can I do that? 1, 2, 4, or dot include, or maybe it's a contain. I think I got this wrong last time. Yeah, cool. Okay. Dot include digit dot length dot count. Okay. Test image display easy counts a digit with 7 segments. Expected 1 got 0. It's because I didn't give it 7 segments, huh? That would help. A, B, C, D, E, F, G. Cool. So that passes, and now what we need to do is go to solution.rb. We need to require relative 7 segment display.rb. We do input equals puzzle. No, not puzzle input. File.read. File.open. Split on new line, and we can actually do a little difference. We can make sure that this solution RB algorithm works. Input file equals / puzzle input, or / test input, and then this becomes input file. Comment this one out for now. So input, we do input.each do input line. And let's say displays equals an array. Or actually, I guess I don't even need to do the array. What we want is count. And then input line, we do display equals 7 segment display dot new input line dot split on space pipe space. Get the second one of those. I figure I'm going to need to change the solution pretty significantly once we get to part 2, so I don't necessarily need to prep this for reuse. So then we just do count equals count plus display dot easy digit count, and put number of easy digits is count. And let's see what we get here. 26, 26. And 449. And that's the right answer. Okay, let's get ready for part 2. Let's see where we're at. Though through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. After some careful analysis, mapping between signal wires and segments only makes sense in the following configuration. So the unique signal patterns would correspond to the following digits, right? Then the 4 digits of the output value can be decoded, right? Therefore, the output value for this entry is 5353, right? Following this same process for each entry in the second, larger example above, the output value for each entry can be determined. Adding all of the output values in this larger example produces 61229. For each entry, determine all of the wire/segment connections and decode the 4-digit output values. What do you get if you add up all of the output values? Right. Okay. So what we need to do is, right, so we've got a decoder, and a decoder is going to take a pattern. It's going to take we can initialize it with a pattern, and then when we send it one of these output values, it should be able to figure it out. And then what we'll do is have the 7-segment display have a new API that takes a decoder, takes an initialized decoder, gives its values, and then we'll sum them up in a similar way. But let's break this out, part 2, and move, part 2. Moves back to part 1, puzzle input to part 1, B to part 1, and test input to part 1, and then we can copy our part 1, part 2. Cool. And cool. Let's go back to here and open up part 2. So we got the puzzle input here, and what we want is a decoder, segment decoder. Yeah, let's do segment decoder and segment decoder spec.rb. Segment decoder, require RSpec, require relative dot dot segment decoder B, describe segment decoder, and right, so we've got the cool, we've got a bunch of tests we can run to figure this out. So we've got the segment decoder, we've got it context, let's call this one the simple pattern. I don't know if I can come up with good names for these, but it is 5 when given CDFEB. It is 3 when given FCADB. It is 5 when, it's only 2 numbers. Okay. Oh, there's actually a third. Wait, why would 3 and 5 be, why would that also be 3? Oh, because it's the same, but they're in different orders. Oh, okay. CDBAF, CDBAF, cool. So that's actually a good test to do as well. It is 3 when given CDBAF. And then, oh, and so we join the numbers, right? 8394, 9781. But that I think can be a responsibility of the display to join those together. So we've got simple pattern, we've got context, complex, pattern 1. Let's see how many of these we need, but it is 8 when given FDGA CBE. It is 3 when given CEFDB. It is 9 when given CEFBGD, and it is 4 when given GCBE. And let's see if that's enough to go on. I'm also going to be doing a let here, since we're going to be doing tests on the same thing. Test decoder and decoder.new. And so for this one, simple test up here, it's going to be given this string. And then this one is going to be, okay, and so this one, it's the first one, right? Complex pattern 1, yeah. Okay. So might need to run tests for more of these patterns, but let's see how far we get without. Let's see if we can find some edge cases where it's going to break down, and then we can go from there. Test decoder decode CDFEB to equal, I don't know, just decode. Let's call it decode. Put that in the decode method. it should equal 5. Right, because the 7-segment display is going to decode each of the numbers given the decoder. Okay. Maybe it actually initializes with a decoder. I don't know. Let's see. Expect test decoder.pcode fcadb equal 3. I kind of feel like if I initialize a segment decoder, I need to change that to. If I initialize a new segment decoder, I should be able to give it values and decode that way. It seems intuitive that you would call decode seems intuitive to me that that's what I would do, or that's what I would expect the method to be. And let's finish these ones up so that I can focus on the implementation. And so here, FDGACBE, expected to be 8. And here we do CEFDB, expected to be 3. And here CFBGD is 9. And GCBE is 4. Kind of feel like this is the API I'm gonna want, but I guess we'll find out. All right, let's go back down to the problem here. Let's run rspec to see it all fail. Initialize segment decoder. Cool. Initialize, and it's going to be a what are these called? The range digits. Signal patterns. And then we've got a decode method. Decode, and it's a digits, digit pattern. Cool. And now we should fail because we're not getting the right answer from the method rather than the method not existing. Cool. And let's see. So we have two things going on. So we know that there's position 1, 2, 3, 4, 5, 6, 7. So there's 7 positions. Each of the letters can be in any of the positions. And then what we need to do is figure out which position it corresponds to, and then take the string that we have, put them in those positions, and figure out what number that would be. So I would kind of want a public method here that I could give it A1, B2, or let's say 1, C equals 3, F equals 6, give it CF and get a 1 back. But I don't know Well, actually, I can do... I wonder if I can inject that dependency to get that to do that. Do I want another class that's like a segment segment displayer or a 7-segment number? That'll probably make the implementation really nice and give me something testable. So in the interest of doing this how I would do my day-to-day work, I'm going to do that 7-segment number and spec or be so I tend to think about like what is the API that I want and just build that. And what I really want here is in decode. I want to figure out what positions the wire letters are in, and then have a class tell me what given those wire letters what number, given the wire numbers, the setup, what numbers do we have? So that's what I'm gonna do. Require RSpec, and it might mean that we're going into part 2 after work, but so be it. It was bound to happen at some point here. Require .. /7-segment number.rb and do, and then let's say context or what is it? Context or describe digit. And so digit's going to take a base case, or let's say default case, and that's where all of them are going to be like they are in this input here. So let 7-segment number and what do we want to have here? So when A is in 1, B is in 2, C is in 3, let's see what happens if we do a hash that has this A1, B2, C3, D4, E5, 1, 2, 3, 4, 5, 6, 7, yeah. F of 6 and G of 7. And so then we just do it is 1 when given CF. It is 0 when given A, B, C, E, F, G. It is 0 when given G, F, B, A, C, E. Just a random order. It is 9 when given A, B, C, D, F, G. And that seems like a decent set of tests here for this one. I've got 15 minutes. Let's see if I can get through this without doing more tests. Usually have a different input and change that around, but it seems like enough for an implementation for right now. If I have bugs, I can add more tests later, but test 7 segment number. And so test 7 segment number dot digit expect CF to equal 1. There's a lot of typing. We can fill these in and fill the test cases in after that. A, B, C, E, F, G, 0, 0, G, F, B, A, C, E, and A, B, C, D, F, G, 9. Okay. So here, now we've got class 7 segment number as pattern. And it's also got def digit, or maybe not pattern, it's connections. Let's say wire positions. Okay, and so now 7 segment number. Why not? Part 2 spec 7 segment number. What did I do wrong here? It's because it's relative. It's always good to run your tests first so that you know they fail and they fail for the right way. Cool, so that's that. We got and so let's see, what we want to do is figure out, given C and F, it was a 3 and a 6. And we want to look up 3, 6. We want to look up 3, 6 or 6, 3 and have that correspond to that number. It doesn't matter which ones, we just need to have that it's got both of those. And the same for the other numbers. So what does that mean? So that means can we do, say 1, 2, 3, 4 dot include 1, 2? False, damn. Is there an include all method? No. Let's say see what methods we have. Difference. Maybe difference. One reverse it, take while. let's see. So if we have 3, 6, difference, 6, 3, nothing, 3, 6, difference, 3, 6, nothing. And so if we do, let's do the same for 9 here. So 9 is going to be 1, 1, 2, 3, 1, 2, 3, 4, 6, 7. Right. 7, 4, 3, 6, 2, 1. Cool. I think I can do it that way. What we want to do is I'm sure there's actually probably a way in Ruby to do it as a switch statement, huh? Where we call .difference on each of the numbers and return, but I don't know. I'm not going to be able to figure it out, and time pressure's weighing on me, so actually we got the pattern, we got letters equals pattern dot split on every character. We want to do values equals letters dot map letter, and then letter dot or wire position sub letter, and so that'll give us the numbers. And then what we want to do is just return 0 if 1, 2, 3, 4, 5, 6 difference values equals 0. Return 1 if 3, 6 difference values equals 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 5, 6, 7, 8, 9. And so 2 is 1, 3, 4, 5, 7. 3 is 1, 3, 4, 6, 7. 4 is 2, 3, 4, 6. 5 is 1, 2, 4, 6, 7. 6 is 1, 2, 4, 5, 6, 7. 7 is 1, 3, 6. 8 is 1, 2, 3, 4, 5, 6, 7. And 9 is 1, 2, 3, 4, 6, 7. And that should all pass? No. Why did we get nil, huh? Did I not save? Right, difference.count. I guess it's actually a empty array And rather than do the count, I think it makes more sense that there's nothing in there. Expected 1, A, B, C, D, F, G, right? Because it's, no, that's wrong. Okay, what did we get wrong with 9? A, B, C, that's because I counted wrong. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. Well, that's fun. Let's see what is going wrong then. And it looks like part 2 is actually going to be the implementation, because I'm not going to be able to finish this in 5 minutes. Okay, so we've got values 1, 2, 3, 4, 6, 7. Ooh, okay. That's the problem, huh? So for 1, I guess I don't have to do these in order. I can put the ones with fewer at the end. I guess that's actually the kind of the simplest way that comes to mind. Let's put these in length order. And then the test will pass. That's not ideal, but what can you do? We got 4 minutes before stand up. Maybe I will see where we're at for segment decoder. Decode digit pattern. So what we'll do is require relative ./7 segment number. Since we're going to be using a 7 segment number in here. Did I write the test for segment decoder spec? Yeah, okay, so I've got that, and we know we're going to have signal patterns. So I only have a few minutes left, so I'm going to try to set things up for myself so when I come back after work today, I can finish this up. And right now, it really just decode pattern. And then once we've decoded the pattern, we have the 7 segment number, which takes a wire positions, digit pattern, and that's all we need to return there. But we need to figure out what the wire positions are. And to do that, I think will probably take me more than 2 minutes. But well, I got the problem fresh in my mind. I can try to come up with some kind of scratch solution to give myself something to work with. So what we want to do is we've got signal patterns, and we need to turn them into something like this. I'm going to turn an object into a single digit. So we've got wire positions equals hash, and it's got an A, B, C, D, E, F, G, B, C, D, E, F, G. And they're arrays right now, but we'll probably change that. Basically going to figure out what possible positions they could be, and keep looping through and removing ones that they can't be until we have a single one, and then maybe change it into an integer from an array. But yeah, that seems like I'm on the path. I just need a little bit more time to code this up. Anywho, gonna change the title of this. Can I change the title while I'm working? Yeah. Save part 1, and I will be back around 6 or so Eastern time to finish this up. Thanks for following along. I'll see you later. How do we